In the world of data analysis and machine learning, evaluating the performance of binary classifiers is crucial for making informed decisions. ROC curve and the AUC are two powerful tools that helps in this regard. So in this video, we'll break down both these curves in the simple technical terms and will provide a relatable real-life example to help you understand their significance and practical application. So let's get started with what is ROC or Receiver Operating Characteristics Curve. Basically, an ROC curve is a graphical representation that shows the performance of a binary classifier. It plots the true positive rate against the false positive rate at various threshold settings of the classifier. In simple terms, an ROC curve helps us to visualize how well a classifier is able to distinguish between two classes, example positive and negative. A real life example, let us say you are building a spam detection system for emails. Your classifier can classify an email as either spam or non-spam. You want to see how well your classifier is doing in detecting spam emails. So here the ROC curve provides a visual representation of how effectively your classifier is identifying true spam emails, that is true positive rate, while also showing the proportion of non-spam emails misclassified as spam, that is false positive rate. And by examining the ROC curve, you can evaluate the trade-off between the true positives and false positives in your spam detection system. So to create an ROC curve, you need a set of predictions and their corresponding true labels. For each prediction, you can calculate the true positive rate and false positive rates by varying the threshold of the classifier. Now there, true positive rate is the proportion of true positives or correctly identified spam emails out of actual positives, that is all spam emails. Whereas this false positive rate is the proportion of false positives or the emails classified as spam but are actually not spam out of all actual negatives, that is all non-spam emails. Here the ROC curve plots true positive rate on the y-axis and false positive rate on the x-axis. And the ideal classifier will have a high true positive rate and low false positive rate, which will result in a point in the top left corner of the plot close to 0, 1. And it's worth noting that ROC curve is useful for comparing the performance of different classifiers or different settings of the same classifier, especially when the classes are imbalanced. That is, one class has more examples than the other. So let's understand it better using a Python code. Now this Python code example creates an ROC curve using sklearn library, assuming you have some dummy data. So this example will create a synthetic data set, train a binary classifier and plot the ROC curve. So first install sklearn if we have not done it already. Remember to install matplotlib if you haven't already done it to visualize this ROC curve. Now let's create the dummy data and plot the ROC curve. Now this code will generate a synthetic data set, train a logistic regression classifier and plot the ROC curve with the area under the curve displayed in the plots label. Here the plot will show the trade-offs between the true positive rates and the false positive rates for the different thresholds. So this is the result which you will get when you will run that code in the Google Colab. Then comes area under the curve. Now this area under the curve is a matrix used to evaluate the performance of binary classifier based on the ROC curve. It is a single value that summarizes the classifier's performance across all positive threshold settings. Now here the AUC or the area under the curve is calculated by taking the area under the ROC curve, which ranges from 0 to 1. Now AUC of 1 means a perfect classifier, while AUC of 0.5 indicates that classifier that performs no better than random guessing. So in simple terms, AUC is a measure of how well a classifier can distinguish between the two classes, example positive and negative, by looking at the entire ROC curve. The higher the AUC, the better the classifier is at distinguishing between the two classes. So let's take a simple real life example. Let's continue with the same spam detection system. Here the AUC will give you a single value that summarizes the performance of classifier. Here High AUC value will indicate that classifier is doing well in detecting spam emails or high true positive rate, while minimizing false positives or low false positive rate. So here the classifier with AUC close to 1 would be considered excellent in detecting spam, while a classifier with AUC close to 0.5 would be performing poorly and maybe guessing randomly. And it's worth noting to adjust that AUC is a useful metric for comparing different classifiers or different settings of the same classifier, especially when the classes are imbalanced. AUC is a great choice when the cost of false positives and false negatives are not equal, as AUC takes into account the trade-off between the true positive rate and false positive rate. So let's understand it better taking a Python code. So here it's a simple Python code example to calculate the AUC using sklearn library, assuming that you have some dummy data. And this example creates a synthetic data set, trains a binary classifier and calculates the AUC. First is install sklearn if you haven't already done. Then let's create the dummy data and calculate this AUC. This code will generate a synthetic data set, will train a logistic regression classifier, and will calculate the AUC using the ROC curve and AUC functions from sklearn.metrics. The calculated AUC value will be displayed in the console. And it is worth noting that you don't need to visualize the ROC curve to calculate this AUC. AUC value summarizes the classifier's performance across all possible threshold settings. You can also run this code in the Google Colab and you'll get the value around 1 by running this code. Thank you.